Okay, so what are the safety considerations that we have in the LNG industry? What are the conditions that we might have some, safety consideration? I mean, the accidents that might happen, some risks that we have. So we have to study all of them. We have to consider all of them, and we have to plan some mitigation systems for those hazard conditions. So LNG industry, like any other industry, especially chemical industry that are producing chemicals, and most of the time they are subject to, like the chemicals are toxic or flammable. So LNG is the same type of industry, is chemical industry, and is subject to the same routine hazard and safety consideration. Okay, is almost the same hazard and safety conditions that might happen, that might occur in any industrial activity. Risk mitigation system. Mitigation systems are like those systems, okay? Like when we are talking here, like when I talk about system, it's not necessarily, some hardware. It can be softwares, it can be some soft skills. Let's say risk mitigation, it means, like some systems that we design, we plan to decrease the risk, okay? So this can start from, fire protection system. I don't know, like from like some hardwares like safety valves, switch valves, emergency valves, emergency shutdown, to soft skills like training your operator to follow, all the instructions, the protocols. All this together can help us to minimize the risk that we have in industry like energy. So the risk mitigation system, it has to be in place to reduce any possible occupational hazard for our workers, as well as to make sure that we are protecting our surrounding communities, and as well as the environment. So the communities, occupational, the operators that are working on the LNG plant, the communities that are living around the LNG plants, and also the environment, the nature, the natural environment around the LNG plant, they have to be all protected. So, first of all, LNG operators, okay, they have to conform to all relevant national and local regulations, standards, and codes. So, like, this is the first step. When you hire a new operator, when he starts or she starts working in the plant, he has to be familiar with all the codes, standards, regulations that you have either nationally or locally, and he has to follow all of them to ensure a safe working place for everyone. There are, some accidents that happen in the LNG plant, but not. Like the good thing is that not a lot of accidents happen in the last few years. From the beginning that LNG plants they start operating worldwide. So there are some major accidents that I'm going to talk a little bit about this later. So one of the major accidents happened in Cleveland is east of Ohio, that there was a gas explosion in this plant. It happened in you have a Wikipedia link. You can go study more about it. It happened in October 1944, and what happened? Like they had three LNG storage tanks. One of them, the vapor, the LNG vapor from one of them was leaking, and it led to explosion, and it killed 130 people, and it destroyed about 1 square mile area of the east side of the Cleveland in Ohio. Okay, so uh, we have to make sure, okay, that we have a, in case of any accidental release of LNG, we have a safety zone around the facility. The facilities are located far enough from, the living communities to make sure that we will protect. We will protect them from any, like injuries or damage or fire. So this case is one of the case in Cleveland, the gas explosion in the Cleveland is, I can say, is a major LNG plant accident that happened in the history, with about 130 people that were killed, unfortunately. So, to make sure that we have a safe operation in the LNG plant, we have several layers of protections, or several layers of critical safety conditions. Depending on each of these conditions, we will, depending to the condition that we have, each of these steps, each of this layer of protection, they will be activated. Okay, so we have totally four critical safety conditions, plus that is all these safety conditions, they are all integrated with the industrial standards and regulatory compliances. Okay, so those four safety conditions is critical safety condition is primary containment or relief, secondary containment, safeguard system, and separation distance. All these, conditions, safety conditions, critical safety condition has to be considered, and protection related to each of them has to be in place. And all of them, they have to be integrated with the standard regulatories that we have, either national, local regulatory compliances that is available. So, the industry standards, why we have to write the standards and everybody has to follow. Let's say there is one accident happen in an LNG plant. Okay, then you are a manager of that unit, that LNG plant, and your head of unit, your manager, your supervisor asks you why this happened. So like you have to convince them that you follow some standards, right? You cannot operate the plant based on your thoughts or based on what you prefer, right? There is a protocol, there is a standard that you have to follow. Or for the unit that you are managing, you have to make sure that you have all those, protections, layers of protections, fire detection or fire. General occupational safety. They have been all followed. Let's say if you have a few operators working in that unit, you have to make sure that they are following all the safety. They are wearing the safety equipment. They follow the occupational safety standards, instructions. Why? Because at the end, in case if there is an accident, you can say that yes, based on the standard that we have, we follow this standard, but this happened for this reason. Okay, but if you don't follow those standards, then you can be accused for any accident, and then you don't have any answer to your supervisor or your manager. So this is the so the standards are, and also the let's say the governments, the officials, the government or the public officials, sometimes they have to make sure that different industries in the country they are working properly, they are following the standards, they are they are not damaging the communities, they are not damaging the environment. So there should be a standard. Everyone will follow that standards, and then if there is any kind of evaluation, so you just follow that standard for the evaluation. So it gives you a more efficient evaluation for the safety, security, and environmental impacts of your industry, or in this case, in case of this course, which is LNG facilities. And regulatory compliances, they should ensure transparency and accountability in the public domain. Okay, so you have to make sure that the regulatory compliances lead to a transparency in the industry, that the industries are transparent. They don't hide anything from the public, and are accountable. They can be they will be held accountable in case if there is any accident. So as I said, we have several layers of protection. Now we will have more focus on LNG facilities. We have several layers of protection, critical safety condition. That the first one is primary containment. Okay, so in the first, primary containment is the first step of protection and is the most important safety requirement that we have in the LNG plant, and that is to have a safe contained LNG. It means we have to store LNG in the suitable materials. Okay, so we have a very strong, very well designed and constructed storage tank with a suitable material that we can handle, we can keep, we can store, we can transport LNG. Okay, so this can be done by appropriate engineering design. That for sure, like those are some figures of different type of LNG storage tanks that we have. So this for sure, like LNG facility is kind of, now we are having almost 80 years, almost 70, 80 years, this industry is available, it's been developed. So for sure, there are a lot of good experience, good development in designing such a tanks. Secondary layer is to make sure, the second layer is that, okay, first layer is designing a good tank. Second layer is that in case the tank is leaking or spilling, how to protect the environment around the tank. Okay, so first of all, we try our best to design a perfect tank, but the tank can leak. The tank can spill for any reason, for any damage, for any environmental like condition, any surrounding condition, it can leak. So we have to then design, in case if that tank spill or leak, how to contain or isolate the tank. So this can be done, okay, by some isolation. Okay, so for example, for onshore installation, if the tank is installed onshore, we can design some kind of dikes and berms. Like in this photo, I have shown the dikes and berms. That is kind of such a area around the tank that we prepare, we fill it with concrete or any kind of isolation material in case you have a spill of liquid or vapor, so it doesn't contaminate. The contamination doesn't go to the land or to the soil. It will be just collected in this dike area. Okay, this is one of the way that we can protect the environment around the tank. Okay. So in some installations, a reinforced concrete tank surround the inner tank that normally holds the LNG. Okay, so it's saying that in some cases, okay, we can have a concrete tank. Okay, around the main tank, we can have a concrete tank. The main tank, which will be the inner tank, will be inside that concrete tank. So in case you have a split or leakage from the main tank, so still you have another layer of tank that will prevent the liquid or the chemical to go outside. So another type is that we already talked about it when in the unit, I don't remember the number of unit. I think it was unit 9 or 10 that we talked about. I think it was unit 9 or even 8, I'm not sure. It was when we talk about LNG storage and LNG transportation. In that unit, I talk about, I talk about the design of LNG tanks that are, like we have single contain, sorry, we have single containment LNG tank, we had double containment LNG tank, and we had full containment. So if you remember in that unit, so I talked like in single containment. So you have one concrete on the ground. In the double containment, you have concrete on the ground and concrete wall on the side. Okay, and for the full containment, you have on the ground, on the walls, and also on the top. Okay, so full concrete, full containment LNG tank is uh, another way to release, to prevent any, I mean, like the leakage or the spill to go to the environment, and this is mainly used in the onshore LNG storage. Okay, so and safeguard system is the third layer of protection. Okay, so now what the safeguard system does. In the first layer, we make sure that the tank has a good design and is very well constructed. In the second layer, we make sure that in case the LNG leaks or spill, we have designed, some kind of system to prevent the LNG to go to the environment. Okay, to contain our environment. In the third layer, is that in case there is a spill or leakage, how to minimize this leakage, how to minimize this spill, and how to make sure that this leakage or spill doesn't damage, the communities around, or how to kind of stop it. Okay, so this is the third layer. The goal is to minimize the release of LNG and mitigate the effect of release, to decrease the effect of release. In case if it's released, how to decrease the effect, how to minimize the effect of this release. So, in this system, the first step, okay, the first level of protection, okay, is first of all, we have to design a very accurate, suitable gas, liquid, and fire detection system. Okay, so we will put several sensors that can detect the gas, detect the liquid or fire. Okay, so this can, I mean, rapidly detect any kind of gas, liquid, or fire, and based on that, it can, and is usually there are like some sensors that are installed in the facilities, and they can be controlled remotely, and they can be automatically shut down or turn on or turn off. And these are, okay, I mean, like they are also connected to the control system of the plant. In case if they detect fire or detect gas or liquid, they can close or open some corresponding valves. They can open or close the valves, input to the tank, exit of the tank, this kind of adjustment. Okay, operational system, like if you have a good procedure for operation, if you have a good training of your operators, if you have a good emergency response, they all can help to prevent and mitigate the hazards. Okay, and moreover, regular maintenance of this system is also necessary, is also very critical to their reliability. So there is, a procedure that every few months you have to inspect all this system, the sensors, their operation, and sometimes maybe in the college, in your university, or sometimes if you are living in the residency area, there is, safety inspection or fire inspection that they check, the sensors. Sometimes they do like a fake alarms to see what will be the response of the people who are working there. So those are the kind of regular maintenance to make sure that the systems that we have designed are reliable. And the last layer of protection or critical safety condition is to have a separation distance. So there are some, there are some kind of engineering fields that they prepare such a maps that you can see here. That, let's say, they see like this is. Imagine this is your facility. You have some tanks, pressurized tank in this point. So then like they can detect that in case this tank explode, what will be the pressure around this tank, or the concentration of the gas around this tank, like as you can see, like based on as you go further from this tank, the pressure, or it can be any kind of parameter, the concentration of the gas decrease. So like for this safe zone, okay, safety zone or safe distance, like you have to follow the regulations that are available, okay, that to make sure that your site, your plant is located in the safe distance from any adjacent industrial or communities or public area. Okay, that in case you have an accident, like the public, the community around, the industries around, they won't get affected. So, for example, in US, there are safety zones around the LNG ships, okay, while they are underway, okay, and while they are also docked, while they also reach to the port, to the terminals. So either while they are on the sea underway, so they define some safety zone for them, like the ships, they cannot get close to them, closer to a certain distance. And also once they are arrive on the terminals, they have also a safe zone, safe distance, that you cannot get closer to them than that distance. And this safe distance are based on the vapor dispersion data that is available, LNG vapor data, and also the thermal radiation counters, okay, and as well as the other considerations that are in regulation. So you have to know, you have to see, based on the history of the operation, what was the amount of vapor that is dispersed to the air when you are loading, unloading, what's the thermal radiation intensity in that side. Let's say when the sunny, warm climate of Qatar, for sure, this thermal radiation, has to be taken into consideration. Uh, very, very accurate. So, okay, standards. So, um, industry standards and regulatory compliance, that is mainly um, using some standards that or some codes that are available, okay, for the operation. So like those standards that we have to follow to make sure that we have a appropriate operation and maintenance procedure. The personnel, the operators are appropriately trained and ready to operate the plant. And also we will use several code references and publication by recognized and corresponding organization to prepare such standards. And to prepare any of those layer of protection, there are some codes, there are some references, there are some publication by several organizations. Three of the main organization in the LNG or in general natural gas processing is the first one is the Society of International Gas Tankers and Terminal Operators, SIGTTO. Then we have Gas Processors Association, okay, Gas Processors Association, GPA. and also National Fire Protection Association, NFPA. Those are the three associations that they provide standards code, reference codes for operation of LNG plants. So, about LNG, about the potential dangers or hazards that we have from LNG, from the LNG properties, the potential hazard that we can have. So it's like, first of all, we have to know what is the LNG properties, at which condition it is stored. So like based on those properties, we can consider, some potential risk, potential accident. So first of all, we need to know what are the properties, and to know that what will be, like, based on that properties, what will be the specific potential hazard that can occur. So as I know, many people, they think like those LNG tanks, they are under pressure, very high pressure. Okay, that is not true actually. Why? Because LNG is an extremely cold liquid at minus 180, minus 160, 70. So it's it's a liquid, first of all. It's not vapor, right? It's a liquid, extremely cold liquid that is formed through the refrigeration and is not stored under pressure. Okay, the pressure of those tanks is not high. Okay. So this is kind of, as I say, common misunderstanding or misperception that LNG is a pressurized substance. Yes, under some condition, the tanks can be pressurized if the like the temperature increase. So for sure there is gas that goes to the vapor phase. This vapor phase can increase the pressure and so on. But in general, in the normal condition, the LNG tanks are not under pressure. So LNG, that is mainly methane. Okay, LNG or natural gas is mainly methane. Methane itself is not toxic. I mean, it's toxic at high concentration. Not maybe the word toxic is not an appropriate word, but it's like any other gas. If you expose to a gas with high concentration, it can damage your health because your body needs oxygen. So if you are exposed to if you are in a room that there is a lack of oxygen, so it can damage your body, right? So but in general, methane is not toxic. It's not like H2S. H2S is very toxic gas. Okay, like H2S or even carbon monoxide are toxic gas, but methane is not. So but like any other any other gases, okay, when it is exposed to the air or oxygen, okay, or when it is vaporized from the LNG, it can cause some breathing problems. It can cause asphyxiation. Okay, it's kind of choking effect, that because of the lack of oxygen. Okay, so if you are exposed to a large concentration of LNG vapor, so you can have some breathing problem and some serious damage to your body. And this can happen if you are exposed to a high concentration in the unventilated, ventilated and closed area. LNG, it has lower density than water, is lighter than water, so it can float on the top of the water. It doesn't mix inside water since its density is less, so it can float on the top of water, and since it can float on the surface of water, it can vaporize rapidly and it can return to the gas phase. Okay. So if it's not properly and safely managed, the LNG itself can be flammable because it's methane, okay? But this can happen only can be flammable or even explosive, and this can happen really under a very certain condition, not at any condition. In general, methane, methane gas, it doesn't explode or it doesn't catch fire or ignite in every condition. It can like ignite when there is enough oxygen, and especially when it is in in its flammability range. Okay, so this range is when the ratio or the mixture of the gas vapor to the air is about 5 to 15%. This is by volume. So when you have in the container or in the room that about 5 to 15% is methane, okay? I mean, the ratio between methane and air is 5 to 15. So in that case, methane might ignite. So, and for this ignition, you need a source of fire that is usually can be a flame or a spark. Okay. So based on this information, the LNG facilities are designed, okay, based on some standards or procedure to eliminate this hazard. I mean, to eliminate any source of flames or a spark, okay, and also they are equipped with extensive fire detection and protection system to detect any kind of flame or a spark that can occur. Because this flame or spark, they can be source of ignition. Uh, okay, if LNG is a spill on the ground or on the water, okay, and it can, as I said, it can go to the gas phase and it can create the LNG vapor, okay? But this LNG vapor, it doesn't get ignited, it doesn't catch fire, except if there is a source of fire or like a flame or a spark at a high temperature, let's say at temperature about 540 degrees C and above. So if it's a flame or a spark that has temperature of 540 degrees C and above, then that vapor will be consider it can be it can catch fire. If we don't have this condition, the vapor will be dissipate, okay, into the atmosphere with no fire. If we don't have the condition to catch fire, it will be dissipated without any fire. So, as a summary, the LNG itself, okay, poses a little of danger. It's not very dangerous. Okay, okay. As a summary, the LNG itself is not dangerous. It doesn't pose a danger. Okay, as long as it is contained in the good storage tank, or as long as we are transporting it, with a good piping, proper piping system, or we are, handling it in equipment designed for this LNG cryogenic condition. And so, in summary, it's not dangerous, the LNG itself, because at very low temperature and very low temperature and low pressure, but the vapor that is resulting from LNG spill or leakage, it can be kind of like hazard, okay, and this it can be dangerous only in the certain condition that as is explained, if it's like the vapor in the condition like flammability range, or it is in contact with the source of ignition like flame or sparks. So here in the last few slides, I have some examples of, like the accident that we had in LNG plant. So the first one that I talked about it a little bit at the beginning is October 1944. The East Ohio Natural Gas Company, uh, there was a gas explosion in the East Ohio Natural Gas Company. So one of the tank, as I said, they had three storage tank. One of the tank, there was a failure in one of the tank, LNG tanks, that there was a leakage of um, and okay, I mean, like that plant was kind of those first LNG plant that was developed globally. So they didn't have maybe a lot of experience. So the tank, it didn't have a proper dike retaining wall. It didn't have any dike or retaining wall. The reason is that the tank was made during the World War II. And in that time, like during the World War II, the countries, they were fighting with each other. They needed, metal was any type kind of metal was very, like valuable because they were fabricating, tanks, weapons, missiles with metals. So metal was very, like valuable item. So in that case, maybe, they didn't use a proper metal, for metal material for the tanks. And the tank was made of steel. Okay, the tank was made of steel with an extremely low amount of nickel. So you usually need a good alloy for your tank. So it was made of steel with a low amount of nickel. So that was the reason that the tank was fragile, brittle, when it was exposed to the very cold LNG. As I said, the metals properties can change at low temperature, right? So in that case, the tank just ruptured, split LNG to the CT sewer system, and the vapor was formed on the ground. And then there was for sure source of ignition, and then that explode, and it killed about 130 people or even more. That was the major accident that we have in the history of LNG process. Another case was in October 1975. The October is apparently is not a good month for LNG processing, anyways. So in October 1979, another accident happened in Louisville, in Maryland, in U.S. It happened in the Cove Point LNG facility. One of the pump sealing failed, that it released LNG vapor, gas vapor to the atmosphere, and then it was entered and settled in the electrical conduit. Once the workers switch off the circuit, the electrical circuit breaker, it created a kind of a spark, a source of, ignition, that the vapor ignited and killed the worker. And it also caused a very heavy damage to the surrounding building. So there are articles, publications that the national fire codes, they were changed and updated, they were modified as a result of that accident, right? So if the worker could, first of all, if the pump, those vapor could be detected, then you could see an alarm that there is a vapor leak. Okay, this can be detected by many type of sensors. And then if there was those vapor, the worker, and if the worker had, if there was a good standard fire code, so the worker knew that vapor is flammable and it can ignite in the presence of a spark or a flame. So he could manage to not to touch, the not to touch the not to touch any switch, any electrical switch and so on. So that's why they updated all the codes afterwards. So, and another recent accident happened in is a recent one. It happened in January 2004 in Skikda in Algeria. There was an explosion and Sonatrach LNG liquefaction facility that killed 27 people, more than 80 people they were injured, and 3 LNG trains was destroyed, and based on the reports, the LNG production of the plant reduced down by 76% for that year. Okay, so it's like a huge loss of money. What happened in that plant? A cold hydrocarbon leak occurred, and there was a cold hydrocarbon leak for the failure for one of the piping or equipment. Then the hydrocarbon gas was drawn into the combustion air. So you have a reboiler, you have a steam boiler, in the plant for many reasons. So like the boiler, usually they, that are creating a steam, they burn, some gases, they burn fuel. So for burning that fuel, they need the air. So that hydrocarbon vapor was drawn with the combustion air to the reboiler, okay, to the steam boiler that was at high pressure. So what will happen once it was drawn? There will be an explosion inside the boiler firebox, and then that explosion precipitated another larger explosion of vapor that was outside the box. That was a huge damage to the plant. As a summary, so we need to apply the hazard and effect management process that is called HEMP, hazard and effects management process. This should be applied for all parts of LNG plants. So this includes identification of hazard or any critical condition, assessment of the risk. We have to assess what are the risks that we have. Let's say if my system is reliable, my operators are reliable. So those are all as risks that we have to assess. And this can be done, by some methods that is called, for example, risk assessment matrix, RAM. Analysis of the hazards. I mean, what will happen in case if there is a dangerous situation, there is a hazard. So this will be also done by using some tools like job hazard analysis, GHA, and human reliability analysis, HRA. Those are all the tools that we will use to evaluate our operators, to see what will be the reaction in a hazard situation and so on. We need to also consider necessary controls and recovery measures, control system, the multiple layer of, critical safety conditions, they have to be all considered, well designed and implemented. And as I said, the LNG itself is a liquid at low temperature and low pressure. It doesn't pose a huge danger, but as long as it is contained, as long as it is inside a storage tank, piping and equipment that is designed to undergo those cryogenic conditions, it doesn't pose any danger. But if it's a spill or leak, or if it's converted to the liquid, to the vapor phase, in the certain condition, it can be dangerous. It can be a hazard issue that we have to plan all those conditions when we designing the plant. So that was all about this unit, and I hope you enjoy it. Please let me know if you have any question. Thank you.